Okay, welcome to our 2.7 concepts video where we're going to be learning about another really cool application of derivatives called elasticity of demand. And this is an economics term, economics business term. And what this is it's a way to measure demand equations. We know that if we have a product that we're selling, that the quantity we're able to sell depends on the price we set the product at. So quantity is a function of the price. And we consider this my demand function. Well, what elasticity is elasticity is a way to analyze these demand functions to look at, should we raise prices? Should we lower prices in order to maximize our revenue? And elasticity has its own formula. So this is my elasticity formula. And the important thing with this formula is it uses calculus because it uses this derivative in the formula. Why? Why do I end up using the derivative? Well, I'm going to try and make this explanation kind of quick because you don't necessarily need to know this to complete all the homework, but it's just a really cool understanding of where this formula comes from. The elasticity formula is built off a concept known as relative change. We've seen this notation before. Delta x just represents your change in a value, change in your x value. But if I divide that by what the current x value is, what I get something known as relative change. How is it changing relative to what it's currently at? And a lot of times what you'll see it multiplied by 100 in order to convert it to a percentage. So this would be my percent relative change. And so just to throw out an example here to help us make sense of it a little bit, let's say I change the price by $1. I increase the price by $1. So that would be my delta x, that would be my triangle x, my change in x. But if the current price is $3, what's my relative change? My relative change ends up being this 33% increase. And you'll notice that's different than if I still change the price by $1, but the current price is $100. In that case, I just have a 1% increase. And so that's the idea of relative change. It's how much are you actually changing the price relative to what it currently is. So with that in mind, now that we understand this concept of relative change, the elasticity of demand equation is a ratio of your different relative changes. So it calculates the relative change in your quantity compared with the relative change in price. So delta Q over delta X over X. That's where this elasticity formula comes from because it's comparing your relative changes. And you'll notice it actually doesn't matter whether you're converting it to a percentage or not, because what happens if you're multiplying by 100 on both the numerator and the denominator, those really just cancel. So if I mess around with this a little bit, I can flip and multiply by the bottom fraction, and I get delta Q over Q times X over delta X. And then, of course, multiplication is commutative, so I can switch the order around here, and I get delta Q over delta X times X over Q. Well, first of all, what's Q? Q is my demand equation. It represents quantity, which of course is a function of the price. So I can replace that with d of x. But what about delta Q over delta X? What does that look like? Well, we should recognize that as an average rate of change. And there's a reason why we're learning this after learning about differentials, because what did we learn in the previous section? If delta X is relatively small, I can estimate this value using the derivative. And so I'm going to replace that with just what the derivative is. The derivative of Q, which of course Q is a function of X. I use d of X, and so my derivative is just d prime of X. And so then you'll notice that I'm pretty darn close to what I wrote out for my formula already. I've just rearranged the order a little bit. The only thing that's missing is, where does this negative come from? Well, the reason I add a negative to my elasticity demand equation is when I take the derivative of my demand function, remember, what relationship should we always see with demand functions? If I increase the price, the demand will go down. So there should always be this negative relationship between quantity and price. And therefore, d prime of x is always going to be negative. And so to compensate for that, we just put a negative in front of my elasticity of demand equation. Okay, so let me transfer that equation back down here. And now we know where this equation comes from. It's just me comparing the relative changes. So now that we understand where this formula comes from, now we can think about how we actually use this formula. Well, you'll notice that with elasticity of demand, what's my input? What does x represent? X represents price. So this elasticity formula helps me analyze different possible prices. So let's say I input a specific price. We're going to say P for a specific price. And I end up getting a value greater than 1. What does that tell me? Well, remember, the elasticity formula is this ratio of the relative change in quantity compared with the relative change in price. If my elasticity is greater than 1, this means that the relative change in demand is greater than the relative change in price. How do I know that? Because if your number is greater than 1, that means your numerator is bigger than your denominator. And what was my numerator? My numerator was the relative change in quantity, and my denominator was the relative change in price. So this tells me that the relative change in demand, or quantity, is greater than the relative change in price. So if I switch that and say, if I plug in a specific price and it ends up being less than 1, I get the reverse conclusion, that the relative change in price is greater than the relative change in demand. Let's do with one last scenario, and that's just if the elasticity equals 1. We'll never get an elasticity of a negative value because, remember, we include the negative with the formula so that my value always ends up being positive. But if your elasticity is equal to 1, that means that the relative changes are equivalent, right? Because your numerator is equal to your denominator, giving you a value of 1. This first scenario we consider elastic, where your elasticity is greater than 1. If it's less than 1, we consider that inelastic. And if it's equal to 1, we call this unit elasticity. So how do we use these results to actually make financial decisions or make business decisions about what to actually set our price at? Well, let's look at this first situation where it's elastic. Remember, we're plugging in a specific price. We're trying out a certain price and then analyzing what the elasticity there is at that price. So the real question just becomes, based off this result, should I raise or lower the price? That's really what the question boils down to, because we're trying out a specific price and then we're getting our elasticity result. Well, in this first scenario, we learned that since my elasticity was greater than 1, that the relative change in demand is greater than the relative change in price. So what happens if I raise the price slightly? Because the relative change in demand is greater, then just making a small change in price is going to have a big effect on my demand because the relative change in demand is greater. So if I raise the price slightly, it's going to end up with a large decrease in demand. Remember, we're always assuming that increasing the price will decrease the demand. And since the relative change in demand is greater, we're going to see a large decrease in demand, even if I only raise the price slightly. But that means the other direction is also true. If I just lower the price slightly, then I should see a large increase in demand. And so therefore, should I raise or lower the price? I should lower the price. So if a price is elastic, I should lower the price. But now let's look at the next situation. What if the price is inelastic? I try out a price and my elasticity is less than 1. This tells me that the relative change in price is bigger than the relative change in demand. That means if I change the price, it's not going to affect the demand at the same quantity. It's going to have a smaller effect on the demand, which means if I increase the price by a significant amount, it's only going to decrease the demand by a small amount because the relative change in price is greater than the relative change in demand. So therefore, I can get away with raising the price because it's not going to affect the demand significantly. So if I'm a business owner, I want to raise the price because I can get away with it. It's not going to affect the demand by a lot. Because similarly, if I try lowering the price isn't going to make that much difference. I'm not going to get that much more demand by lowering the price because the relative change in demand is smaller than the relative change in price. That leads us to our last scenario, unit elasticity. If I end up with an elasticity of 1, what should I do? Well, you can probably guess I should just keep the price the same. That means I've done it. That means I've reached the optimal price that's going to optimize my revenue. Okay, but that's the concept behind elasticity of demand. So things to remember as you go into your homework is first of all, there's your formula, but you can also find this on the formula sheet. And then just remember those 3 different outcomes that you can get when you plug in a price. Okay, go ahead and get started on the homework. And then when you run into trouble, go ahead and check out my examples video. Good luck.